let's talk inverse trig functions. And the way you'll see an inverse trig function written most frequently is like this. So you have sine or cosine or tangent with a little -1 that looks like an exponent, and then you'll have whatever you're taking the inverse sine or cosine or tangent of. Another way you might see this sometimes written, this is kind of an old-fashioned way of writing it that you don't see quite as much anymore, is with the letters ARC in front of it. So arc sine or arc cosine or arc tangent. The reason I point that out, in addition to the fact that you may see it on some problem I give you because I find it from an old resource. The other reason I give that to you is because my favorite calculator is the Google search bar. And if you want to do an inverse trig function in the Google search bar, that's the easiest way to do it, is by typing in arc sine or arc cosine. That's a lot easier than doing like a little -1 as an exponent. So I just wanted to point that out. Either way you write it, though, what you're doing or what you're saying is this is the inverse sine or the inverse cosine or tangent of x. And what you're asking is what angle is going to give you a sine of x. So it's a way of starting with the sine, the cosine, or the tangent, working backwards and figuring out what angle would get you there. So here's a little example. We know that sine of pi over 4 is square root of 2 over 2. So think back to the unit circle, kind of think where that is, and the sine of pi over 4 is square root of 2 over 2. So what we can say then is the inverse sine of square root of 2 over 2 is pi over 4. So it's a way of working backwards. And it's very similar to the relationship between exponents and logarithms. The inverse trig functions kind of undo the regular trig functions. Here's another way to think of it, and this might help see kind of where this could be useful. Because, like I said, the same thing applies for sine, cosine, and tangent. So let's make a right triangle and kind of think back to when you first learned about sine, cosine, and tangent with right triangles. Let's say that we have a side of 7 and a side of 10, and we have this angle here. And we don't know what this angle is, but we know what its tangent would be, because tangent of, let's call it theta, since it's an angle, tangent of that angle theta is going to be opposite over adjacent. So it'd be 7 over 10. And that's great that we already know that we have the 7, we already know we have the 10. That doesn't really help us with anything except just what the tangent is. However, if we use the inverse function, what we can do is then use this information to figure out what is the measure of that angle. So if you can take the inverse tangent of 7/10, then that will tell you what your missing angle is. So it's a way you can use distances and lengths and work backwards to figure out what angles would give you those lengths. So it's a pretty handy little tool to have. I will say, though, for a lot of values, the only way you're really going to be able to do this is to plug it into a calculator, which is why I say Google search bar and type arc sine or arc cosine or arc tangent. Okay, one last point to make before we really get into this. Inverse sine and inverse cosine, inverse tangent, these are different than cosecant, secant, and cotangent. And I think one thing that gets confusing is sometimes in math we use the words inverse and reciprocal interchangeably. And part of the reason, I think, is because multiplication and division are inverse operations. And so when you do take a reciprocal, you kind of are doing an inverse. But for trigonometry, it's really important to remember these two words are talking about totally different things. So if we're talking about a reciprocal function, we're talking about cosecant, secant, and cotangent. Those are the functions where we take the sine, the cosine, or the tangent, and we flip them. If we're talking about an inverse function, and that's what we're getting in today, where you start with the sine, the cosine, and tangent, and then use that to work backwards to find what angle would give you that value. So we're going to take these one at a time, starting with sine. So it tells you the domain here of inverse sine is -1 to +1. And the reason is no matter what angle you're working with, positive or negative, no matter how big or small it gets, if you take the sine of that angle, it will give you a number in this range. So numbers greater than or equal to -1, less than or equal to 1 are the only numbers you can plug in to the inverse sine function and get an answer in return. So here's another thing that comes up though, is if you pick any number in that domain from -1 to +1, technically there's an infinite number of angles that could give you that result. So if you look down here on the unit circle, and you'll learn what this blue arc means in a second. Let's say we want to do the inverse sine of 1/2. So what angle would have a sine of 1/2? And if you remember the unit circle, we're talking about which angle would hit the outside of the circle at a point where the y value is 1/2. And the first angle to do that is pi/6. So we could say the inverse sine of 1/2 is pi/6. However, if you continue going around the circle, you'll find, well, there's another angle right here that would have a sine of 1/2 that would produce 1/2 as a y value. And that angle is 5 pi/6. And really, you can just keep going. You can go around the circle all the way around, come back here, and if you've done one full rotation plus another pi/6, now you're at 13 pi/6, and that would also have a sine of 1/2. And that isn't even getting into negative angles. I could go backwards around the circle and find even more angles like -7 pi/6 and -11 pi/6 that would still give me that same value. And if I wanted to spend the time, I could come up with hundreds and thousands of them. So this is really important. When we take the inverse sine, we are specifically looking or thinking about angles that are greater than or equal to -pi/2 and less than or equal to pi/2. So looking at the graph here, and let me erase some of this other stuff that I just drew. We are only looking at that blue arc. So when you take inverse sine to find an angle, to find what angle gives you that sine, your answer will come from this part of the unit circle. And it's only going to come from that initial rotation. You're not going to go around multiple times. So the range of possible values you get for inverse sine is from -pi/2 to pi/2. So you're only taking from that right half of the graph. And in that right half of the graph, you can get an angle that would give you any sine that you could possibly ever calculate. So that's all you really need. All right, moving on to cosine. And if this is confusing, I think when we do the examples and you're looking at the unit circle, it'll make a little more sense. Inverse cosine, the domain is also from -1 to 1, same idea, because that's all you can get from a cosine function is numbers in that range there. For inverse cosine, we're not going from -pi/2 to +pi/2. Instead, we're going on the top of the graph right here. Because remember, cosine is your x value. And on the top of the circle, that gives you every possible positive and negative x value you could ever get as a cosine. So that will cover all the possibilities. So when you're doing cosine, you're on the top of the graph. Sine, you're on the right half of the graph. All right, I know I went through that one kind of quickly. It's very similar to sine though, and so is tangent. The couple of differences with tangent, just because it's a little bit different of a calculation than sine or cosine. The domain of tangent is all real numbers, because a tangent, you are not constrained between -1 and +1. Remember, tangent is sine over cosine. And if you remember the graph of tangent, you can get very big numbers going up to infinity and very small numbers going down to negative infinity. Like sine, when you're taking the inverse tangent and you get a result, it's coming from the right half of the graph. Again, that will give you all of the possible answers you could want. There's one slight difference, though, in the range of inverse tangent and the range of inverse sine. For sine, we had like the hard brackets. But for tangent, we have these parentheses. So I'm not going to go over why that difference is right now, but I want you to think about it, and we'll talk about that in a Google Meet later this week. So just keep that in mind right now. All right, let's get into some examples. And for example, to work out these problems, you're going to want to use the unit circle. And this is a little blurry of a unit circle. Hopefully you can see it okay. But I wanted to get something that had all the radian measures and also had all of the sine and cosine values. So remember, sine is y, cosine is x, going around this circle. And before we actually do the examples, I do want to fill in the tangent values as well. And remember, if we can fill in the first quadrant, then everything else kind of takes care of itself. So remember, tangent is sine over cosine. So let's do the tangent of pi over 6. So the sine of pi over 6 is 1/2. The cosine, the x value is square root of 3 over 2. So I'm doing this right here, finding the tangent of this angle. And the 2's cancel out, so I get 1 over square root of 3. I rationalize the denominator, and I end up with square root of 3 over 3. So tangent of that angle right there is square root of 3 over 3. So I'm going to erase some of this, get a little more room. So we have square root of 3 over 3. So just remember the stuff in green is the tangent. Now, if I wanted to fill in more of this, I know that if I go straight across right here, the tangent over here is going to be negative square root of 3 over 3. The tangent straight down below here is going to also be negative square root of 3 over 3. And I can also find the tangent over here on this side is going to be positive square root of 3 over 3. But remember with tangent, I really only need the right side of the graph. So these two on the left don't really matter. All right, if I go up to pi over 4, remember at pi over 4, the sine and the cosine are the same. So when you do the tangent and do sine over cosine, it's just going to be 1 because it's just going to be something over itself. And if you go to the quadrant directly below, quadrant 4, you'll get negative 1 at that point because the sine and the cosine are opposites. The only other one we really need to figure out here is at pi over 3, and that is going to be square root of 3 over 2 over 1/2, sine over cosine. And the 2's cancel out, and when the 2's cancel out, this works out really nicely. We just have square root of 3 over 1, which is square root of 3. So the tangent up here is square root of 3, and if you go directly below, down here, it's going to be negative square root of 3. So that's what we need to fill in with the tangents. Like I said, the left side of the graph, it doesn't really matter because we're not going to use that for tangent. Okay, so now if you've got the unit circle handy, all you really have to do is make sure you're looking in the right spot. So sine, inverse sine of square root of 3 over 2 is the first example. So I've got to find something with a sine of square root of 3 over 2. Remember, for sine, I'm only using this half of the graph, the right side, and sine is the y value. So which angle has a y value or leads to a point with a y value of square root of 3 over 2? And I see that right here at pi over 3. So my answer is going to be pi over 3. That is the angle that gives me a sine of positive square root of 3 over 2. And I do have a typo here that I just noticed. For tangent, I did not mean that to be square root of 3 over 2. I meant it to be square root of 3 over 3. So I'm going to There you go. So you may adjust that if you're writing this down also. So I've inverse tangent of square root of 3 over 3. So what I'm going to do is find which angle gives me a tangent of square root of 3 over 3. And we already calculated that earlier, and the angle is pi over 6. So pi over 6 right here takes me to a tangent of square root of 3 over 3. All right, cosine, inverse cosine of negative 1/2. Now remember, cosine's a little different than the other two. Cosine uses the entire top half of the graph, quadrants 1 and 2. So in those two quadrants at the top of the graph, which angle gives me a negative 1/2 as a cosine? And remember, cosine is my x value. So this angle right here, 2 pi over 3, gives me a negative 1/2 for the cosine. All right, next one is inverse tangent of negative 1. So where is my tangent going to be negative 1? And that's something we worked out earlier, and you'll see it is down here on the bottom. Now, here's what I want to do with this. The inverse tangent is negative 1 right here at 7 pi over 4. But if you remember what we said about tangent, the range of values for tangent goes from negative pi over 2 to positive pi over 2. So instead of writing 7 pi over 4, which is not in that range, what I want to do is think, okay, if I went negative, if I went this way, how far do I go? And I would go pi over 4 that way. So I'm going to use negative pi over 4. So remember, if you go 7/4 pi this way, that's the same as going 1/4 pi in the opposite direction. So it's going to be negative pi over 4. So keep that in mind when you're doing sine and tangent. If you go into that bottom quadrant, you will need to use the negative angle measurement. And then the last one here is kind of a trick question. It says inverse sine of positive 3. And remember, a sine can only give you a value between negative 1 and positive 1. If you have a value of 3, there's no angle with that sign. So if you get a number that is greater than 1 or less than negative 1 for sine or cosine, you're going to say undefined. So I hope that makes some sense, and we can have some time to talk about this in class as well if you have questions or you're confused on parts of it. But that is inverse trig functions. So there you go. Good luck with those.